Forward. Okay,
Got it.
let me share my screen. All right, AP Institute mowing. So, let me get rid of this for a second. Problem is, you have a grid, you have some trees, you have a lawnmower. The lawnmower takes it's a 3x3 square. It takes, yeah, 3x3 units. It takes up that much space. You want to see to how many things can you cut? Like how many lawn units can you cut? Problem is the lawnmower can't go through these black spots, which represents trees. So you basically have to print out at the very end. Dang. At the very end, you basically have to print out how many of these lawn units have you cut, and that's represented by C. T is the tree, yeah, and the lawnmower can't go through. Okay. Yeah. Bruh. Oh yeah, I forgot to put that. Is there anything else? Oh yeah, I'll talk about the input later. So that's basically the problem, right? So let's think of it logically. If we start the lawnmower right here, what we do is we move it one to the right. We're like, oh yeah, I can cut all of this. No, actually, I should start like this. Okay, so the lawnmower can go in 4 directions, right? It can go up, down, left or right, right? So, we first try to go down. We realize that's out of grid. You try to go left, it's out of grid. We try to go up. We see that there's a tree, so we can't go up. And then we try to go right. And yay, we can go right. And then we just do the same process. Thing is though, we also have to keep like a matrix that tells us, hey, I've visited this position before, so you don't go on an infinite loop. So you try to go down, it's the end of the grid. You try to go left, you visited that position before. You try to go up, there's a tree in your way. You try to go right. Oh look, I can go right. Same thing, blah blah blah, and then you go right again. And then here you have a tree, here you visited, here's the bottom of the thing, and then you essentially go up. And you just basically do this all the way until everything is, or all the way until it just ends. Like there's nowhere else to go. This, like, let's say we end right here, right? This would be visited, this would be visited, this would be the end of the grid, and this would be a tree. So it's essentially be over at that point. That's the basic thing of the code. Now, do you have any questions, like, about that?
All makes sense.
Okay, makes sense, right?
Yeah.
Okay. Okay, let's talk about the input and then I'll go into how to do it. Okay, so the input, two is how many grids there are. So there's one grid here, one grid here. 12 is the length, I believe, so how many rows there are. And then 11 is the width, so how many columns there are. You basically just use that, you take in the input, and then you do a for loop. For int I equals to 0 while I is less than 12. And then
A nested
another
for loop, basically, right?
nested for loop. Yeah, nested for loop. And then you go through the width, right? 5, 6 here just tells us, okay, so this part was kind of weird. 5, 6, so they're basically going off of this grid, right? That's for the first example. 5, 6 basically just, damn, okay, one sec. Okay, 5, 6 is basically the center of this lawnmower. Where is the center of this lawnmower? So in this example, it's 0 index, so we'd be saying, oh, that's way too big. We'd be saying, this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, and this is 0, this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. So the center of this guy will be right here. So if we move this guy over here, this is where he'll start. Basic explanation of it. Let's try that with their other input. Let's get rid of all these small dots. Okay. Okay, here they're saying its length row. They have 11 rows. They have 13 columns. They start at row 9, column 1. So row 9 would be, no, I'm gonna use a bigger size. Okay, row 9 would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And row 1, I mean column 1 would be 0, 1. So this lawnmower, the center of its thing would be, dang, I want to use another color. The center of
There
its
aren't
thing is
rows
going
the
to
other
be
way
right
though.
here.
What? Okay.
No. Rows, man.
Rows
Wait,
are
give me
left
a
to
sec.
right, right?
That's the center of thing. So this would be right here. Now,
Okay.
wait, what were you saying?
Aren't rows left to right though?
It's like a matrix. It's like a matrix. Um, so it would be row, and then column, column,
Oh,
column.
like that.
Yeah.
Okay. Yeah. Okay.
Okay. So that's the input. You take it in, you get tree. Yeah, that's basically what it is. Do you have any questions logically? I don't think there's
Wait, where do
much
the trees
else.
come from? Like, do you implement them yourself, or they're random or something?
So you're talking about the actual code, right? I'll get to that. But otherwise, do you have anything
Okay.
else, like
No.
conceptual wise? Okay. So how to take in the input? Um, yeah. So what I said before, you do once you get in two, you do like a giant for loop. Inside this for loop, you say like for in I is equal to 0 while I is less than 2. So, and then you just do all your code inside of it, right? Inside of it, you would say take in L, dang, take in the rows, take in the columns, take where this the center of this guy is, take where the center of this guy's row is, take where the center of this guy's column is, and then you're taking in the actual grid. So what you would do is how do I explain this? Okay, so you do a nested for loop like what we said, and since we haven't our scanner for inputting doesn't have a next car like character thing, you know how it has next int, next long,
Yeah. Next
next
card.
line and
Okay.
stuff like that. Since it doesn't have a
Hmm.
next car, all we can do is take it in as an entire string, right? Um, we can do it this in two ways. One, we can do it in next line, which gives us the entire line. What we can do after that is we split it by spaces and then we get an array and then we can base it off of that. Or we can do dot next, which is it just gives us the next string before a space. So it gives us dot, it gives us dot, it gives us dot, and so on, right? So you can do it one of those two ways. I did it the second way, dot next, because like it seemed very easy that way. Um, but yeah, then what did I do? Um, I like to do it. I like to do these types of stuff using int arrays instead of character arrays. So what I did is I made it into an int array. So if it was a dot, I made it a 0 in the int grid. If it was a t, I made it a -1. So that just symbolizes a t, like there's an obstacle there, right? I basically did those two things, and now I have a matrix. Matrix is zeros and -1. -1 here and there, right? Yeah, so now I have zeros and -1s. Um, okay, that's input. And then yeah, you do the actual code, and then it'll repeat that entire thing one more time because this here is a 2, and it'll print both of them. Any questions on that part?
Wait, I'm sorry. Wait, does the user get to choose where the trees are, basically?
You don't get to choose. So basically what you would do is once you're doing, you know how you're doing the nested for loop, right?
Uh-huh.
Um, you'd say if this string dot equals a dot, in your int matrix put a 0 in that position. If it equals a t, else if it equals to a t, then put a -1 in that position in the matrix. Does that make sense?
Okay. Yeah.
So essentially, you would have something like 0. Oh my god, that's way too big. You would have something where it's like 0, 0, 0, dot, 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 lots of zeros, and then this would be a -1. This would be a -1. Okay, that is not a good color, but you get what I mean, right?
Mhm.
Okay, cool. That's our input. Any questions on the input?
Oh, no.
Okay, cool. Then comes the actual code. So, what should we do? Well, we can do a recursive function. I'll get into uh, what like the, I'll elaborate on it as we go on, but like, just keep that in mind, the word recursive function. So, yeah, what we do is we start off the R center, um, R, my bad, where the lawnmower center is, like column, where the, I don't know how to explain this, the mowing guys rows center. You know what I mean? Like the 5 and 6.
Yeah, okay, yeah.
So yeah, let's
Yeah.
call 5 R center and 6 C center, right?
Mm-hmm.
So we take R center, we find where its position is. We take C center, we find where its position is. Now I just marked it as a just one dot. Okay. Essentially, I just have one dot here. So I think it was right here or something. It doesn't really matter. The code will work the same. Oh my god, that is way too big. Okay, yeah. So that's the dot, right? Then what I did was I called my, should I name it DFS? It's the algorithm is DFS, depth first search, or you can do BFS, which is breadth first search. Let's just keep it simple. Let's call it traversal. So we're just traversing the entire array. Okay, cool. So this guy's the center. What we do is we call our traversal function. So this would be outside the public static void main. It's in the same class though. And we'll call it public static void traversal, and we'll pass in the R center. We'll pass in the R center of where the lawnmower is currently at, row and column. So two ints, right?
Okay.
We'll give that in, and then we'll say if we've visited this, let's keep it simple. So we'll also, we'll also create a Boolean visited matrix, a 2D array at the beginning, and we'll initialize it once we get how many rows and columns there are. So once we get that visited array, we'll say if once we get into the traversal function, we'll say if this center has been visited before, then stop, just return, just go
Yeah.
back because we don't want an infinite loop, right? Otherwise, we do the actual code, which is first we set it to visited. We say, hey, this has been visited. Let's set it to true, right? Then what we say is, since we have this, we say check. Let's call it check. Let's make a check function, right? Check is going to basically look towards where the actual lawnmower's boundaries are, which is this all here, right? What it'll do is it'll check, is there, okay, that was a terrible square. I don't want to hit that T. Okay, so that's not hitting the T. So what we'll do is we'll check, hey, is any of these points in this square, this lawnmower square, have a T inside of it, or is any of the squares out of bounds, right? So we'll check, um, is there a T in the square? We'll go through every single point here. There's no
So
T.
you would check if there's a -1, because T is -1.
Yeah, it will check if it's a -1, and then, okay, no. First we'll check if the R position or the row is out of bounds. So if it's less than 0, then we'll check if the row is greater than bounds, which is in this case greater than what, 11. Um, yeah. Don't worry about it. I'll tell you why. It's kind of confusing when you actually code it. But oh, did I say row? My bad. Column. Column is greater than 11, and then um, once we do that, we have to do the same for the rows. We do that first because if we call the matrix, we say, hey, is matrix of R comma R of C equal to -1, and it's out of bounds, then it'll give you an error. So you always want to check the boundary first, right? Um, so we check the boundaries first. We say if it's less, if the thing is outside of the grid like this, stop, just return. If it's outside like this, or like this, or like this, just stop and return. In addition to the first one I just said. So we do all of that first. Then we check, hey, is there a T inside of this? Which would be, yeah, the -1 you were saying. So is this matrix of R comma C have a T a -1 inside of it, right? If it does, return. If it doesn't, then what we want to do is we want to do a for loop, and that's where we do the thing I was talking to you about earlier, which is check left, check right, check bottom, check top. So you do a for loop through all these positions. So you say you talk about where it is at the center. Dang, I don't want this part. You'd say, here, this is the center, right? We'd say, hey, what if we move the center one to the left? What if we move the center one to down? What if we move the center one right? What if we move the center one up? Because either way, our check function is going to check all the outskirts. So we can just play around with the center, right?
Is this in the traverse function?
This is in the traverse function. Yeah. So basic outline, we when the traverse function, if the center has been visited yet before, then we say return. If it hasn't, we say this center has been visited. Then um, we check if this is out of bounds. If it's out of bounds, like the outskirts are out of bounds. If the outskirts are out of bounds, we return false. This public check function is going to be a Boolean function. So return false, and then if it's false, you just return in your traverse function, which stops that thing from executing. Um, if it's all inbounds and there's no tree in it, you return true, and it'll go on, right? Um, yeah. So once you do that, you what do you do? Um, I'll get to the answer later. So then what you do is you do a for loop, right? You do a for loop saying, um, what if I move the center left? What if I move the center right, down, up? So I say, hey, if I move the center to the left, I just say, since we've already done our boundary checks and everything in our traverse function, because check is incorporated in that, all we need to say is traverse r center, which is where the center is right now, r minus 1, comma, c minus 1, or r plus 1, comma, c plus 1, or r
This is
minus 1, comma,
this is
c.
for moving left and right
Yeah,
column, right?
left, right, up, down. So we're just going to call those DFS functions, I mean, traversal functions, right? Does that make sense?
Yeah.
Cool. So we do that, and it by itself is already going to be checking if it's in bounds or out of bounds.
I also when it moves to the next like slot, the center will change, right? Like the R and C, whatever you set it as,
Yes,
or
so
will
it'll be a
change with it.
recursive, right? So once it say that I have this function right here, this guy right here, this center, right?
Mhm.
From it, no, I should probably just put it here. Um, say that I have this guy right. Oh my God. Say that I have this guy right here, right? He has four kids. Four kids. One is going left, one is going right, one is going up, and one is going down, right? Basically, once you get here to one of the kids, you view it as its own parent. Now it's its own thing. It has its own left, down, up, right, right?
Mhm.
If and it you just see it as its own thing. That's the beauty of recursion. Like it'll see itself as its own thing, and that's why we do what we did earlier, which is we check if it's visited, we check if it's inbounds, and then we go into its child, and then we do the same thing. And once it has no more children anymore, let's say it ends right here, right? This is depth first search. You see how it's going all the way down into one of them? So once it does that, then it'll go up and then down to this second child and then see if it has any left, right, down, up. And then it'll go into this guy and then this guy. Once it's done, it'll come back up here and then it'll do it again right here, right here, right here.
Oh, I see. Okay.
See, so that's depth first search, and that's the traversal we're doing. Um, yeah. Once you do that, you basically traverse the entire thing. You now know where this lawnmower can go and where the lawnmower can't. We still haven't written our answer yet, so just keep everything I just said in mind. When we start off, we want to create three global things, right? We want to create the matrix because it's being used by the traversal and the check and blah blah blah. We want to create our visited matrix, visited Boolean matrix, and we also want to create the answer, which is an answer matrix, right? The answer matrix is going to be this thing right here. Okay.
Yeah.
Okay. Cool. So we create those three things. They're global. What we then do, do I want to keep it that complicated? Do I? Let me think for a second if I want to keep it that complicated. If you'll understand. I think I can do that. Okay. So, we have those three things, right? We do the entire code. Inside the traversal though, what we'll do is after you make it visited, what you'll do is you'll set, you know how the matrix is zeros and ones, right? I mean, zeros and negative ones, right? What we'll, yeah, right? Okay, so what we'll do in addition to that is once we've set that position in the visited array as true, we'll set the center, which is like this here. Do I want to do that though? No, actually I don't want to do that. Okay, never mind. I'll make this even easier. So we have the traversal, we have the matrix, we have the answer, and we have the visited. So we use that in our traversal, we use that in our check function. Now, for the actual answer though, what we'll do is, actually, I do really want to make that. Okay. So what we'll do is in our, so in our traversal thing, right, we say make it visited, check if it's in bounds, and then do the traversal through all of its four nodes, which is up, down, left, right, correct?
Okay.
So in that, what we'll also do is we'll say, should I do that? Yeah, I'll do that. Basically, what we'll say is also make the matrix of those positions equal to 1. So now what it will do is it'll, I should just probably use this color. It will make this, let's say our center is right here, right? It'll make this one, oh my god. It'll make, wrong one. It will make this one, it'll make this one, it'll make this one, it'll make this one, 1. Okay? Then once we move the center to here, even though these are already made 1, I should have made that bigger. It'll just go through this entire thing again. It'll make this one, it'll make this one, 1. Even though if they're already ones, it'll just make all the zeros
Okay,
ones.
and 1 is what it's cutting through, basically, right?
1 is what it's cutting through. Yes.
Yeah.
So 1 is where this guy is going. This is just the center. Correct? Got it?
Yeah.
Cool. So once we do the actual traversal and everything I just told you earlier, then we're done. Now the matrix has zeros, negative ones, and ones, right? Our actual output, however, wants T's and C's and dots. So what we'll do is we'll do a for loop at the very end. I mean, in that case, you don't really need to make it global, right? You don't need to make it global. You don't need to make the answer matrix global. But what we'll do there is we'll make a character answer matrix. So a character 2D array, right? And we'll do a for loop, a nested for loop with like two for loops in it. And we'll say if matrix of I comma j is equal to 0, then it's a dot because that's how we initialized it, right? So if it's 0, then put it as a dot. If it's a 1, which it should have been a 1 if it went, oh my god, it should have been a 1 if it went right here. Holy, I did that twice. Okay, it should have been a dot 1 if it went here. So all of these positions would be a 1. So if it's a 1, make array of ij equal to c. You have to make, since you're doing a character array, you have to put it in single quotes. So you have single quote c, single quote.
Wait, sorry, say that again. If C is what?
Okay, so we have the matrix array, right? We do we go through the entire matrix array through a nested for loop. Since it's the matrix array is the matrix 2D array is in zeros, ones, and negative ones. Since we initialized it as if it's a dot, be a 0, if it's a t, be a negative 1, what we'll do is if matrix of I comma j, which is row comma column, if it's equal to 0, then we know it's a period. So we'll make answer of ij equal to period, right?
Yeah.
Okay. If it's negative 1, we make it into t, capital T. So that's a tree, right?
Oh, so this is basically when you're printing the board, it'll come as
Yeah,
T
we're
period
printing
and
it
C.
both. Yeah.
Okay.
And then, yeah, if it's a -1, we print out C. I mean, I said -1. If it's a 1, we print out C. And yeah, that's basically how you do it. Yeah,
All right.
cool. Yeah, just message me if you have any questions. All right. How do I stop the recording? Let's figure this out.